So the other day we started talking about wind, but we definitely did not get super far when we were talking about wind. We did not, but hey, it was pretty windy yesterday, wasn't it?
It was alright.
It was a little windy out there.
Yeah, a little bit.
What was a major difference between, so what, yesterday was Wednesday, between Tuesday and today? What's a huge difference outside?
There's snow on the ground.
Now there's snow on the ground. The wind always happens when there is a major shift in the temperature. I believe we already put this on the top of page 27, right? It's caused by uneven heating of Earth's surface.
Yeah.
Yeah. Now, but what you gotta remember is that uneven heating leads to not just different temperatures everywhere, but different temperatures. So I think you have this already too. Remember, where does cold air go? Cold air sinks. So it's like pushing down on you. That's gonna bring higher pressure. Cold air brings higher pressure. Warm air rises, so it's taking that pressure off of you. So it's less pressure. So these differences in temperature make differences in pressure. And just like osmosis and diffusion and farts, wind goes from areas of high pressure to areas of low pressure. Yes, I did say like a fart.
Ew.
Because when you fart, or when you have to fart, you have high pressure, right, in your butt?
Yeah.
And, oh, okay, because you don't fart. So it goes from areas of high pressure, your butt, to areas of low pressure, the air. So just like wind, I should say just like your fart, wind goes from areas of high pressure to low pressure. Did we get this far? I think this is the first one we did not get to. The greater the pressure difference, the stronger the wind. And I'm sure you guys know where I'm going with this one. The greater the pressure difference before your fart, the stronger the fart. So it's not nonsense. It's 100% true. Do you have a better example? Okay, what I thought.
Wind.
Yeah, wind. That's what I'm talking about. Wind, and I'm comparing it to your fart. So the stronger the pressure difference, the stronger the wind. Which then means we can use those isobars. Here's another bullet. Those isobars that we were talking about with pressure, if they're closer together, we're going to end up with stronger wind. So I have a map that has some isobars on it on the very next slide here, which I'll wait till everybody's, so that you can see what these isobars look like. Because again, that's flashback to chapter 2. So here's a weather map that has pressure on it. So all of these lines connect areas of equal pressure. So again, in case you forgot, it means everywhere on this line has a pressure of 1,000 millibars. Here, 1,004 millibars. So what we were talking about with stronger wind, the closer the isobars, the stronger the wind. So here where these isobars are super far apart, it takes quite a ways for the pressure to change those 8 millibars on this side. But over here, or even, I mean, here's pretty close. Up here, they're closer. So for here, it took that long to change 8 millibars. Here, it's only taking that short distance to change 8 millibars. So the wind is going to be faster and stronger here to the west of the Great Lakes than it is over here to the east of them. One last thing that's important about wind, and notice I made this one big and bold and capitalized. Winds are named for the direction they blow from. So add that last bullet, underline it, highlight it, circle it, star it, write it in capital letters. Wind is named for the direction it blows from. Why is that helpful? helpful to know where the wind is coming from? How about if I said we have a northerly breeze, and knowing that it's named for where it comes from? So if it's coming from the north, how does that what information does that give you? Yeah, so we know it's gonna be colder air. So if the wind is coming from the north and it's named northerly breeze, that's going to tell you it's coming from the north, and you can expect colder weather with it. If we have a southerly breeze, you can expect, because it's coming from the south, for it to be warmer. Or if you have a breeze coming from the ocean, so you have what's called a sea breeze, what might you expect with that? It actually depends on what time of year, if it's gonna be warm or cold, but knowing it's coming from the water, what can you expect with that? No, water.
Water. Oh, wet.
Wet, so you can expect some wetter or more humid air. So knowing where it comes from gives you a little hint about what kind of weather to expect. What? No, not right now.
No.
I'll turn these ones off for you. Because I've mentioned before how you need to know the names of the instruments and what they measure. So we've already learned a thermometer measures temperature. We've already learned a barometer. What does that measure? Barometer. Air pressure. We've already learned about our sling psychrometers. What do they measure? Dew point and relative humidity. A hygrometer, which is another version of those that measures relative humidity and dew point. And then these two guys are the last ones. An anemometer and a wind vane. They both have to do with the wind. What do you think is the difference here? What do you think the anemometer is doing with those cups on the end?
Spinning them.
The wind will spin them. And what do you think we use that? Why is that helpful?
Chicken.
This isn't the chicken one, and this one isn't going to measure direction. This is going to measure wind speed. So you guys have this exact picture in your packet. I'm not sure if you have room at the top or at the bottom. I think you guys have more room at the bottom, right? So by an anemometer, we're going to label that one wind speed. So what'll happen is the wind will catch in these cups, and you can count how many times it spins per minute or per second. And the wind vane, which you typically see on a barn with a rooster on top of it, right? Anybody ever seen one with something else?
That's a made-up picture.
My grandpa,
Real.
huh?
Real.
It is real, yeah. My grandparents had one with a pig on top. I don't know. What do you think the wind vane measured? This one's wind direction. That's why it's got the north, south, east, and west on it. So like I said, a lot now, you do need to know these instruments, what they look like, and what they measure, and their names. So now we're going to go a little bit more in depth about some wind, and you have these exact pictures in your packet. And so we're going to kind of put all the stuff we've learned about the last few weeks together here. So first of all, we have this picture and the next picture. Can you look in your packet and tell me the difference between the two pictures?
The moon and the sun.
The moon and the sun. What do you think I'm trying to depict with there being a sun in one picture and a moon in the other?
Daylight.
Daytime or daylight versus nighttime with the moon. So if that did not register, that's what I was doing. Please label the one with the sun daytime and the one with the moon nighttime. Now, at the beginning of this chapter, we learned about land and water during the day and at night. What did we learn about water when the sun is out? Water heats up slowly. Does everybody remember that? The pool heats up slower than the pool deck. So that's actually, what you're gonna see here is I'm gonna have a set of notes. There's going to be 4 bullets on this side and 4 bullets on the other side, just to give you an idea of how big or small you have to write. The first bullet is exactly what you just said, water heats up slower than land. So go ahead, right on the left of your picture there, add this first bullet, water heats up slower than land.
I thought water is way warmer at night than during the day.
I feel like we might have learned that last chapter, beginning of this chapter. Remember that water heats up slower, but also cools down slower. And by the way, why does it have heat up slow and cool down slow? What's that? You don't remember where it's in your reference table? What?
Not flash, like power filter.
No, it's in your reference, the concept. Come on, say it. You have to look on the front cover for the answer. How about the rest of you? Front cover, do we find why water heats up slower than land? We got, what's the name of that concept? Specific heat. That's the next bullet, by the way. Water heats up slower than land because it has a higher specific heat. Remember, that means it takes more energy to heat up the same amount of water than it does land. Now, because it's heating up slower, is it warmer or colder than the land? Because it's heating up slower, is it warmer or colder? It's during the day. Yeah, because it's heating up slower, it has colder temperatures, or at least cooler temperatures. It doesn't mean it's cold, but it's cooler. So there's your third bullet, cooler temperatures.
Did we go over why water is warmer when it rains? Like the pool.
The pool is still warmer than the pool deck, is that what you're talking about then? Or the air?
The pool is warmer when it rains than the pool does.
Again, because it takes it longer to cool down because it's got that higher specific heat. It loses energy slower. All right, here's flashback to Tuesday. So we're not going too far back in our heads. Because it's cold, the temperature of the lake is cooler, meaning the air above it's cooler. Which way is the air going then? Is it rising or falling because we have cool temperatures here? What does cold air do, guys? Cold air sinks. That's the fourth. 1, 2, 3, fourth bullet. Cool air sinks because it's cool air. Now I'm going to draw that over here. Oh wait, because the air is cool, we have high pressure or low pressure. Which way is it going? Down or up? Down. So do I have high pressure or low pressure now?
High pressure.
That's high pressure. Cold air sinks giving us high pressure. I'm going to draw that over on the picture too. I have high pressure, air pushing down. Kind of a lot of concepts, but everything you knew already. You knew that water heats up slower than land. You know that the pool stays colder than the pool deck during the day. It's because it has high specific heat. Because it's heating up slower, it has cold temperatures, we know cold air sinks. And because it's sinking, we feel that high pressure. Let's go over to the land and work through the same stuff. It's during the day. The land heats up. Faster, slow, guys. Land heats up faster than the water because it has a lower specific heat. Since it's heating up slow, or this time it's heating up faster, the land's heating up faster because it has a low specific heat. Because it's heating up faster, is it warmer or colder on the land? If we're heating up fast, is it warmer
It's gonna
or
be
colder?
hot.
It would be hot, it would be warmer. We got warmer temperatures. We know that warm air rises. And because it's rising, we have less pressure on our body.
Water. Leave us alone.
All right, so we got that low pressure now. Low pressure because the warm air is rising. And then what I say about farts, which way do they move? I mean, which way does wind move? From what to what? Yep, in this case, not concentration, but high pressure, same concept, you'll get it. I'm good with that. Wind always blows from high to low. So with this one, is it blowing from the lake to the land or the land to the lake? If we're going high to low pressure. Which way is it going? Lake to the land. And because so add that arrow for the wind, please. So the wind is going from the lake to the land. This is officially called a sea breeze. Again, it's named for where it comes from, so it should probably be called a lake breeze in my example. But it is the concept that during the day, there's high pressure over the lake, low pressure over the land. So now we gotta turn this around. Talk about it during the nighttime. So it's still gonna be similar, so keep in mind how much space you need to give yourselves for writing. It's going to be about the same amount of writing for the nighttime picture. So let's switch it up to nighttime. At night, what do we know about Lake Erie? How's it? What's happening over the water? Water.
Yeah, right.
Oh, it does, no doubt. Let's talk about heating and cooling, and we're at nighttime. Is it gonna be cooling off or?
Like cold.
Okay, so the lake, does it heat up fast, or does it cool down fast or slow?
So,
It cools down slower, which means it stays warmer longer. This is exactly what Carter was just talking about. The pool stays warmer at night because it cools down slow. And again, that's because water has a higher specific heat. This will give us warmer temperatures over the lake at night. Does warm air give us high or low pressure? Think this one through, guys. Does warm temperatures give us high or low pressure? Low pressure, because remember, warm air rises. The next bullet, air rises, giving us low pressure over the lake. So let's talk about the land. What do we know? Land heats up, or since it heats up fast, what does it also do? Cools down fast. Yep, land cools down fast, which is because it has a lower specific heat, giving us colder temperatures at night on the land. Cause it's cold over the land, does the land have high pressure or low pressure then if it's cold? High pressure, cause cold air sinks. And if it's sinking, it's pushing down on the land, so it has high pressure on the land. And remember, just like fart, which way do winds blow? High to low. So in this case, it's blowing from the land to the water. This is called a land breeze. Why? Because it's blowing from the land. They're always named for where they come from. So, I don't know if you're making this connection. It's always windy at the beach. Did you know that already? You ever been to a beach?
Yeah.
Yeah, those of you who haven't, unfortunately, I would love to take you on a field trip, but I can't. Right now, let's go to Lake Erie right now. It's super fun there. Yeah, we'll hit up Sunset Bay right now, right?
Yeah.
Perfect weather for it. Back in 2020, we used to go to that's where I took my kids all the time. We did our remote learning from the beach. It was nice in that March, not this.
Jack used to go with that.
Yeah. So it's always windy at the beach.
Back in my
A lot of people fly kites at the beach. We always bring a kite when we go to the beach because it's always windy there.
Why?
Why? Because it's always windy there because of what we just walked through, that it's warm air over the land during the day, and it's gonna blow during the day, it's gonna blow from the water to the land, and at night it reverses the other way. There's also, I'm not sure, because you guys probably don't go that direction too often, but if you travel along Lake Erie from around Hamburg towards Buffalo, there's a bunch of windmills there.
Yeah.
Yeah.
Like when you go to Darien Lake.
Well, we're gonna get to that. I was talking about at Lake Erie first. So no Lake Erie. Yeah, but we're gonna get there in 1 second. So there's a lot of windmills along Lake Erie because it's always windy there. And then my next question is, where else is it always windy?
Darien Lake.
On the trip from here to Darien Lake, what are you going over when you go from here to Darien Lake?
Bridge.
What'd you say?
A road, a bridge.
A rid.
A bridge, divided road and bridge.
I did. I hate when you guys witness my stupidity. I guess I was getting at you're going over a bunch of hills on your way, right? Isn't that what you're doing when you take? Yep, up and down a bunch of hills. So let's talk this through. Why would there be a bunch of windmills on hills? Let's walk through this concept. So, you're telling me that you're going over a bunch of hills on your way to Darien Lake.
I don't do that.
You don't do that well, some of you do. Why would there be windmills on these hills?
Because it's windy.
Why is it windy?
Because you're out higher than that.
So it has something to do with your elevation. What causes wind?
Air pressure.
Differences in pressure. Good. So let's start our trip down here at the bottom of the hill. Compared to when we're at the top of a hill. What's the pressure when we're down here at the bottom?
More.
Why is it more at the bottom of a hill?
Because you're less in the atmosphere.
Right, because you've got all of this atmosphere on you. When you're at the bottom of the hill, you have a ton of atmosphere on top of you. When you're at the top of the hill, you have less atmosphere on top of you. So the pressure is going to be lower here. So which way does the wind blow? Well, from high to low, which in this case is up the hill. And same thing over on this side. They're going to have a high pressure here too. And it's going to blow up this hill. So why not throw in some windmills here? Well, because they create a lot of cheap energy. So that's why you guys have so many windmills here. How come we don't have any windmills here on our?
Not high up there.
Not that we're not high enough, it's just that there's no differences around us. So it's not, if we were just up on like a plateau, that did this, this could be very high, but we're not going to have any windmills here either. Because we need that difference. The fact that on your way to Darien Lake, you're up and down multiple hills is there's lots of differences in elevation there. Once in this case, once you're up this hill, there's not gonna be more wind up here just because it's higher up. Yeah, what are we doing?
How come, like, when I remember something about, like, what people are finding, planes, like, this pressure.
Okay, so what happens, remember how we were talking about equilibrium the other day? Yep, so your eardrums act to kind of balance your pressure, the pressure. So your eardrum, what it's doing is actually pushing out as much as the air that's pressure that's pushing in. So right now, everybody's ears, unless you're sick, are probably at a nice, even like level, pushing in and pushing out at the same. So nobody's winning that battle. But when you go up the hill and there's less pressure coming from the outside, your eardrum is still pushing out as much. So the fact that it's changing so quickly, your eardrum is pushing out more than the air is pushing in, so it gives you that popping or that need to pop your ears. And once you pop your ears or yawn or chew gum or whatever, it regulates itself again. So when you go up in an airplane, it's a real big difference. There's a lot higher pressure on the ground, a lot lower pressure in the air. So again, once that change happens, your eardrums adjust themselves. Same as if you go to the bottom of the pool, you ever go to the bottom and stand at the bottom of the pool?
What, how you get to the bottom of the pool?
If you are a swimmer, you do that.
I don't know how to sit there and go back up. I can't.
No.
You've never done like a handstand and your head's near the bottom of the pool?
Can't, I'll go back up.
Your ear, I bet they do, you just deal with it. That's same with, like, I used to popping my ears my whole ride out here every day, all day long. My husband takes one trip out here, he's like, everybody, my ears are popping. I'm like, yeah, just deal with it. No, sorry. Back to our lesson. The last thing I want to do for today is to kind of jump big time in our packet. Oh no, we are Totes Magoats doing it.
What?
Oh,
What?
I use one old fashioned phrase. Tote Magoat was actually, he was a mascot for the new recycling totes at one point. No. How about this? If I showed you this and asked you that question at the top, what does this mean to you?
3/4 pie.
Looks like a key.
Look, okay. So were you able to tell me anything off of this, you think?
It's 3/4.
Number.
There's 3/4 of what though? Of a pie. Is it pizza pie or apple pie?
Lemon
pie.
Oh my
Lemon.
God. That's what's called a pizza.
Lemon pie.
Lemon, I do like lemon, but not the meringue. Anyway, yeah, Keith,
Cherry
huh? Or cloud cover, if you actually know where I'm going with this. So clearly Keith knows where I'm going with this. If I gave you this, would this help you tell what any of that stuff meant?
Yeah, because I don't want to read it.
Well, tough beans, Charlie. So we were talking about 3/4 because it's 3/4 of the way shaded in. Now that we have this key, it's called the station model explanation. Right here, this arrow shows the amount of cloud cover, and it's showing that it's approximately 75% cloudy. What this is, so what that first thing that I showed you, so what this is called a station model. Station for weather station. A weather station is just simply a bunch of those weather instruments we learned about, all hooked up in one place, so whoever's reading them basically can report that information. Back in the day, they needed to do this as quickly and efficiently as possible. So what they did is they developed this model. that every single meteorologist in the United States would use the same model. And they would send it with as little ink as possible so that they didn't waste any extra. And this is what they came up with. So here's the key for that. So as long as everybody, like if you were in Buffalo and you wanted to send your information to LA, you put it in this station model, and the people in LA would know that this is the key you use to make it. Everybody uses the same key. So for example, in this one, can you tell me using the key, by the way, if you haven't already gathered, we're on page 13 of your reference table.
Are there?
I want to ask you, what's the temperature of this station model?
28.
28, how did you know that, Carter?
That's what it says.
Okay, so right here it tells you in the upper left-hand corner is always the temperature. It also tells you, because it's in parentheses here, that it's always in Fahrenheit. So this bare 28 that had nothing on it means the temperature is 28 degrees Fahrenheit. It is definitely below freezing, yep. So we're gonna keep going around this. The half and this asterisk, according to the key over here, the half is the visibility in miles. So it means you can see, because visibility, hopefully you know that means you can see. If it's visible, you can see it. This is telling you the visibility is half a mile. So if you had a clear shot, like there's no buildings in your way, you would be able to see half a mile down the road. Now the asterisk, the label here tells you it's present weather. There is a key for that symbol, in fact, on our reference table. So here's that, what we were looking at. Here's the key.
No.
Down here is the key for that. So an asterisk does mean snow. So you can see some of the other symbols that we would use to represent other weather. So you do see that there is one for snow and one for snow showers. So apparently those are different in the meteorology world. But what I want to look at all of these. How would you describe all of those types of weather?
Good.
Those are all good. You like rain, drizzle, smog, hail, thunderstorm, rain showers,
Yeah.
snow, sleet, freezing rain, fog, haze, and snow showers. Oh, good. So you've been super happy with the weather this winter.
Yeah.
Yes. In my opinion, those are all yucky weather, right? Do they have a symbol for a bright, sunshiny day?
No, sir.
No. So how do you think on a weather station model they represent a bright, sunshiny day?
No sign.
No signs. Good. So if there is nothing next to that visibility, it just means that it's bright and sunny. All right, let's keep moving around. So then we have dew point on the bottom left. Always going to be on the bottom left. It's always in Fahrenheit.
27.
27. Hey, that's pretty close to the 28 degrees. That's the actual temperature. What does that mean? That the temperature and the dew point are very close. We wrote this in our need to know facts the other day. What happens when the temperature and the dew point are the same or close? Yeah, what's that mean?
Precipitation is happening.
Yes, remember if they're the same, it means precipitation is happening right now. The fact that these two guys are really close means precipitation is very likely, and yes, it's very humid as well. All right, then we got this stick thing coming out of the circle. The stick itself, the long part of this, is telling you the wind direction. Remember, we always name wind for where it's coming from. So this is in the southwest corner. One thing I think you might want to add to this, you got some blank space right here, is just in case you forgot how this works, a little compass. Never
Eat soggy waffles.
soggy worms.
Hey.
So since this is in the southwest corner, then the wind is coming from the southwest.
Soggy waffle.
Okay, whatever, guys. I could manage to eat a soggy waffle. There ain't no way I'm eating a soggy worm. If I have to eat worms, it better be deep fried and crispy.
You never eat it.
You eat worms?
I'm not saying I do, I'm saying if I had to.
Ew.
So in this case,
Ew.
the wind is coming from the southwest. This stick will move depending on where the wind is coming from. So don't always expect to see that in the same spot. The other thing that will change is the wind speed. Notice in this case, there's one long little feather and one short feather. It's telling you that a long feather is worth 10 knots. A short feather is worth 5 knots. So since we have one of each, we have a 10 and a 5. It's a total of 15 knots. By the way, knots is how they measure wind speed officially, and it is just right here. 1 knot is 1.15 miles per hour. So just a little bit more than a mile per hour. Keep going around. They tell you precipitation. It's in inches. It's in the past 6 hours. Now here's pressure, barometric pressure. Can we just put in parentheses there that means air pressure? It is given in millibars. It's abbreviated with literally the world's stupidest abbreviation. We'll go through that abbreviation tomorrow. And then this last one that I actually skipped over, the barometric trend. Guys, what's a trend?
Popular.
Something that's popular, something that's going on a lot right now. So this is telling you what's happening with the pressure. In other words, is it rising or falling? And that'll tell you what's going on with the weather, if it's higher or lower pressure. Again, finally, this is also abbreviated as a really stupid abbreviation, but I'll show you that tomorrow. So that's it for today. We're going to put this together tomorrow and practice a bunch of these weather station models tomorrow. Again, no homework today. If you are not going to be here tomorrow, we are still learning. We are going to do pages 43 and 44 tomorrow. That's it for the whole class. If you don't finish it, it'll be homework. If you're here, trust me, you'll finish it. If you are not here, I am still expecting to see that from you. So 43 and 44 is what we're doing tomorrow, whether you're here or not.
I'm good, no, thanks. This is Lisa,